Hi guys, afternoon everybody. Just let me know if you all can hear me before I start, please. Just put it in chat. Let me know if you can hear me before I begin, please. All right, cool. All right. All right, so I'm going to be doing the June 2019 exam paper, right? If you all are looking for the 2022 January and June, 2021 January and June, and the January 2022, that can be found on my YouTube channel. All right. So in this paper here, I'm going to run through as quickly as I can. Hopefully I can get the whole paper done in class. I hope so. All right. So let me start with question 1 here, right? Using a calculator or otherwise evaluate each of the following. Now, what I normally tell students is that if you have a question like this, especially question 1, and this is in paper 2, they said using a calculator or otherwise, right? I normally tell my students, here what? Use a calculator. You have it there as an option. Go ahead and use it, right? Now, we have a subtraction to do and a division to do, right? Now, the numerator, so what I would do here, right? I'll work out the numerator first, which is 2 1/4 minus 1 3/5, right? 1 sec. Let me just pull up my calculator here as well. Give me 1 sec. All right, so you all should be seeing my calculator there, and what I want to work out, 2 1/4 minus 1 3/5, right? So 2 1/4, so I'm going to press 2 1/4, so we're using the fraction part of our calculator here. 2 1/4 minus 1 3/5, right? Minus 1 3/5, right? So we're going to get 13/20, right? So we're getting 13/20 here. So that's our numerator. So this here is 13/20, and you're dividing that by 3, right? So all we need to do is we already have that information in the calculator. We're just going to divide that by 3. So divide by 3, and you're going to get 13/60, right? Right, so I'm telling you, right, that you should use a calculator, right, because it's a paper 2 and you can use a calculator for that part of the question, right? All right, so that's part A, right? Part 2, we have 2.14 multiplied by sine 75, right? So again, we have to use a calculator for this as well. So you're going to have 2.14, right, sine 75, right? That's the same as saying 2.14 multiplied by sine 75 degrees. What they expect us to do here is to use a calculator, work out the exact value, and then we're going to give our answer to 2 decimal places, right? So let's pull the calculator again. So what we want to do, 1 sec. All right, so I'm going to press 2.14 multiplied by sine 75. So 2.14 multiplied by sine 75 degrees. And I'm going to get 2.067, right? So 2.067 Now, the thing is, the question says that we should give our answer to 2 decimal places, right? Now, we have to look at this and we have to decide what are we going to adjust. Now, this here, this 0 is my first decimal place, right? That's my first decimal place. The 6 is my second decimal place. So this is your first and this is your second. Now, you want to give your answer to 2 decimal places. So this is my second decimal place here. So we need to look at this number that comes right after. Now that number is 7. So therefore, we're going to have to round that 6 up by 1. So our answer is going to be 2.07 as my answer, right? Right, so that's part 2. All right, let's move on to the next one here now. So Irma's take-home pay is $4,320 per fortnight, right? So this question is based on consumer arithmetic now. Now, we are talking about a salary here, right? And some students, when this question came, some students weren't sure what a fortnight is, right? Now, fortnight means that you are paid every 2 weeks. That's what a fortnight means, right? So her take-home pay every fortnight is $4,320. Now, they kind of give us a table here that shows the different items that are used with the salary here. So we have things like rent, food, other expenses, right? And our total expenditure is this amount here. Now, what is Irma's annual take-home pay, right? What is her annual take-home pay? Assuming that she works 52 weeks, right? Now, remember, she's being paid every fortnight, right? Or every 2 weeks. So what I would do here, I would figure out how many fortnights we have here. So the number of fortnights right? In this case here, I'm going to take that 52 and I'm going to divide that by 2, right? So 52 divided by 2 is going to give me what? That's 26 weeks here, right? So she's going to be paid 26 times. So therefore, her annual, right, pay is simply going to be, we're going to take the 4,320 and multiply that by 26. So that's going to give me, give me 1 second. Yeah. So that's 4,320 multiplied by 26. And that's going to give me 112,000. So this here is going to be 112,320, right? So that's going to be her annual pay, right? I hope you guys are with me here. Right, so that's part 1 concerning the salary here, right? The second part of the question, they said determine the amount of money that Irma allocates for rent each month, right? Now, you want to figure out what is rent, right? And that is this amount here. That is X dollars, right? Now, you know that she has rent, she has food, she has other living expenses, she has savings, and we know that when you add up all of those things, that should be equal to her fortnightly pay. So what I'm going to do, I'm going to write down a sum here, right? So I'm going to say X plus 629. So you're going to write X plus 629. You're adding up all her expenditure. 629, you have 2X. And you also have 1750. Right? And that is actually equal to her fortnightly pay, which is 4320. So this here is going to be 4320. Now, what we have here now is a simple equation here that we need to solve, right? So I'm going to keep all my x's on one side and carry all the numbers on the right hand side. So I'm going to have x plus 2x is equal to 4320, right? Minus, because the 629, when we carry it across here, it becomes negative 629. You have to subtract the 1750 as well, right? So x plus 2x is going to give me 3x. And then I'm going to work out 4320 minus 629 minus 1750. And you're going to get 1941. Right? So therefore x is equal to 1941 all over 3. And you're going to get $647. Right, so that is part 2. Let's see what else they want here now. So all of Irma's savings, right, is used to pay for her son's university tuition costs, which is $150,000. If Irma's pay remains the same and she saves the same amount of money each month, right, what is the minimum number of years that she must work in order to save enough money, right? Now you have to read these questions carefully. They said that her savings, all of her savings, right, goes towards this tuition cost here for university. Now let's go back to the table. Let's see. Right, so savings, right? Her savings in this case is 1750, right? So this here, right? That's the savings, right? But she's trying to get to this amount here, right? Now, some students work this question in slightly different ways and they got slightly different answers, right? So we need to be a little careful here. So all I'm going to do, I'm going to take that 1750, right? And I'm going to multiply by 26 because we have 26 fortnights in a year, right? So I'm going to take that 1750. So savings per year, right, is going to be that 1750 multiplied by 26, right? If you all remember, we previously got the 26 by taking the 52 and divided by 2, right? So 1750 multiplied by 26 is going to give me 45,500. Now, this is the amount that she's saving per year, but she's trying to get to this goal here, right? So the number of years to save that money, right, is simply going to be the total amount of money she needs to get, right? And she needs to divide that by how much she saves in 1 year. Right? And you're going to get about 3.296. Sorry, 3.297, right? Years. Right? Now this is how much the length of time she's actually going to take to save this money, right? But the problem is the question says the minimum number of years, right? So we're not going to write this as our answer. What you're going to write as your answer is one above that. She's going to take 4 years to do this, right? So your answer here should really be 4 years. You're not going to put 3.297, right? Right, so that's the third part. Let's see what else we have here. So actually, so that's the end of question 1, right? Now question 2 in the exam is going to be based on algebra, right? So this part 1 here, we have to simplify and simplify completely. So we have 3p squared and you're multiplying that by 4p to the 5th, right? Now, when you have a situation like this, all we do, we multiply the numbers first. So 3 by 4 is going to give me 12. P squared multiplied by p to the 5. We're going to use one of our indices rules, which looks like this. A to the power m multiplied by a to the n. All we do, we add our indices. So we're going to say m plus n. So in this case here, since you have the same base, we'll be talking about p squared and p to the 5th. It is going to be p to the power 2 plus 5. So our final answer is going to be 12p to the power 7, right? So that's our answer for that part. For the second one here now, we have a fraction. 3x over 4y cubed is a fraction. This here is also a fraction. And what we are trying to do is to divide this thing. So all we're going to do, when you're dividing a fraction, this is what we normally do. We have 4y cubed, right? Now when you're dividing by a fraction, all you do, you change the sign to multiply, and you must invert this here. You have to invert this. So this is going to be 20y squared over 21x squared, right? Now, some things here are going to cancel for us, right? So let's see what can cancel here. So this 3, right, can go into this 21 here 7 times. This 4 can go into this 20 5 times, right? So now we're going to try to simplify some things here. So let's multiply our numerators. So you will end up with 5xy squared on top all over 7x squared y cubed, right? Now, this is not our final answer because it said to simplify, right? Some things can reduce here as well. Now, watch what's going to happen here. This x can go into this x squared x times. This y squared can go into this y cubed y times, right? Now, some of you all wondering, well, how you getting that? X over x squared, right? It's the same as saying x to the 1 divided by x squared, right? If I apply my division rule for indices, this is going to be x to the power minus 1, which is the same as saying 1 over x, right? Now, let's deal with the y squared now. Y squared over y cubed is the same as saying y squared divided by y cubed. So this is going to be y to the power 2 minus 3 is going to give you minus 1. So again, this is 1 over y. Now, what does that mean for our answer, right? Now, the final answer here is simply going to be 5 over 7xy, right? That's what our answer is going to be, 5 over 7xy. All right, moving on, because I want to try to complete the whole paper if I can. All right. Okay, we have a question here. We want to solve this equation here. We have 3 over 7x minus 1 plus 1 over x is equal to 0. Now, lots of students had great difficulty when they were trying to work this problem from the real exam, right? Now, when you have a question like this here, what I would do, right? You're really trying to add two fractions. And the two fractions that you're trying to add is this. 3 over 7x minus 1 plus 1 over x. So what I would do, I would add this first of all, right? So when you are adding two fractions, what we normally do, we have to find our LCM. Once the denominators are different, I can write the LCM as x, open brackets, 7x minus 1, right? You just multiply the two denominators here. Now, what am I going to do next? So what I need to do now, I need to take this here, which is my LCM, and I'm going to divide it by this. So watch carefully what I'm doing here. I have x, open brackets, 7x minus 1. That's my LCM. I am dividing that by 7x minus 1. Now, this will cancel with this, and you will end up with x. Now, what do you do with that x? This x here has to be multiplied by this numerator here. So this here is going to be 3x, right? That's what's going to be there. You write back your plus sign, right? And we're going to take the LCM again, which is x by 7x minus 1. And you're going to divide that now by this x here, right? Now this x will cancel with this, and you will end up with 7x minus 1. Now what do I do with that? I'm going to take that now, and I'm going to multiply by this numerator here. Now I know the process may seem strange, but that is exactly how you all add a fraction, right? So this here is going to be 7x minus 1. When I simplify the numerator, I'm going to get 3x plus 7x is giving me 10x minus 1 all over x by 7x minus 1, right? So that's when I add the fraction. So therefore, this here, right, can be replaced by 10x minus 1 all over x, open brackets, 7x minus 1, right? And all of that is equal to 0. Now, even if some students had reached this stage here, they weren't sure what to do next. Now, if I take 0 and I divide it by any number, I'm going to get 0. If I take any number and I divide it by 0, I'm going to get undefined. If you try to do it on a calculator, it's going to tell you an error, right? You can't divide by 0. So the only way that this expression here can be equal to 0 is if your numerator is equal to 0. So therefore, what you have to do is to say 10x minus 1 is equal to 0. So therefore, 10x is equal to 1, and therefore x is 1 over 10, right? Lots of students had great difficulty with that particular question, sorry, right? All right, so moving on. When a number x is multiplied by 2, right, the result is squared to give a new number y. Now, in your syllabus, it says that we have to be able to translate words into an equation, right? So we have a number x, you're multiplying it by 2. Now, what that means is that you're doing this: 2 multiplied by x. That's what multiply by 2 means. Now, the result is squared to give a new number y. So what they're saying is this: you are squaring that to get a new number y. And they want us to express y in terms of x, right? Now, if I square 2x squared, now please don't go in the exam and write this. Some students do this. When you have to square this, some students will say, oh, this is 2x squared. If you do that, you'll get that wrong, right? What we have to do is to square the 2, and we have to square the x. So when I square this 2 here, I'm going to get 4. When I square the x, I'm going to get x squared, and this is going to be y. Now they said express y in terms of x, so I'm just going to reverse it. I'm going to say y is equal to 4x squared, right? Now, the next part of the question here now, they said determine two values of x which satisfies the equation y is equal to x and the one that we just got. So the equation that we just got was y is equal to 4x squared, and they are telling us to find two values of x that satisfies this equation, which is y is equal to x. Now lots of students did not realize that this here was a pair of simultaneous equations, right? That's what this is. They gave us an equation, y is equal to x, and previously we worked out that y is equal to 4x squared. So if I call this equation 1, and I call this equation 2, essentially what I have here is a simultaneous equation. So therefore, I can write, since both of them are equal to y, you're going to write 4x squared is equal to x. Now some students are not sure how to solve this. Once you see an x squared, right, it's a quadratic. Once your highest power of x is squared, it's a quadratic. And if you're trying to solve a quadratic, all we need to do is to carry everything across onto my left-hand side here. So this is going to be 4x squared minus x is equal to 0. Now I have a quadratic that is easy to solve. All I need to do is to factor out x. So this is going to be 4x minus 1 is equal to 0. So now when I solve this, I'm going to get two values of x. So I can say either x is equal to 0, that's one solution, or my second solution is 4x minus 1 is equal to 0, 4x is equal to 1, and therefore x is equal to a quarter, right? So those are my solutions. X is equal to 0 and x is equal to a quarter, right? Hope you guys are okay so far. Alright, so if you all haven't done so as yet, please hit like and subscribe to my maths channel here, please. Right? Alright, now, third question. Right? Using a ruler, right? And using a ruler, a pencil, and a pair of compasses only, construct triangle NLM, in which LM is 12, MLN is 13. Now, what I normally advise students to do, before you even try to construct anything, try to sketch your diagram first, right? Sketch your diagram first and then work from there. So I have a line LM, so I'm just going to draw a line, right? Because we need to know what this thing is going to look like before we do anything. So this is LM, right? And it's just a sketch with pencil, right? Nothing fancy. So LM is 12, right? MLN is 30 degrees. So you're doing something like this, right? So just label what they're telling us. This is 30 degrees. And LMN is 90 degrees. So what they're saying is this. This here is 90 degrees. And this point here is going to be N, right? And this here is 12 cm, right? Now, they don't want us to use a protractor, so we have to use a compass and pencils only, right? So let me show you how to handle something like that. Alright, so first things first, right? Let's now. So we need a ruler, right? We need a ruler to do this. We also need a compass, because we're not using a protractor, we're using a compass, right? Now, how do we do this? Now remember, LM was 12 cm, right? So what I will do, I will first draw a line that is longer than 12 cm. So this is step one. You take your ruler, right? One sec, I don't like the green. Right, I'm going to draw a line here, and I'm going to draw it longer than 12 cm, right? Let's say, yeah, about 15, no matter, right? Now, the next step in the process, to make sure you have 12 cm, you're going to take your compass, and you're going to put it next to your ruler, right? And you're going to open it so that it is actually 12 cm. Right, so that's around 12 cm here. Now I'm just showing you the process. May not be accurate. So what I'm going to do, right, I'm going to draw an arc so that I know exactly where 12 cm is, right? Right. Now let's do all the labeling here one time, right? So this is L, right? This here is going to be where M is, and we know that this here is exactly 12 cm. Now please, when you are drawing these diagrams, guys, you need to draw the arcs. You're getting marks for the arcs, right? So that's 12. Now we need to construct a 30-degree angle at the point L, right? Now to construct a 30-degree angle at the point L, what I will do, I will first construct a 60-degree angle first, right? So that's your step, right? You want to construct a 30-degree angle, you must first construct a 60-degree angle and then bisect that angle, right? So here's what I'm going to do. If I want to construct a 60, This is what I do. I draw an arc like this, come across here, I'm going to draw an arc there. Now the thing is, if I were to do this, if I were to take my ruler, place my ruler here, right, and I were to draw a line passing through those 2 points there. Now I'm going to use a different color here to just show you what's happening here. This angle, right, that angle there that I'm going to get is actually 60 degrees, right? This angle here, right, is 60 degrees. But I don't want 60 degrees, right? What I really want, I want 30 degrees. So I need to bisect that angle. Now there's no need to adjust your compass again, right? You can use the same opening that you have right now, right, to complete this construction here, to get it 30 degree. So what I'm going to do, right, so the first step in bisecting an angle, you would have had to draw an arc, right, but that arc is already here for us, right? You would have had to draw on this arc here, and what you'll have to do is to come to this point, right, and what I'm going to do, I'm going to draw a large arc here, right, move this here, put the pointy part here now, right, where those two arcs intersect will allow me to get that 30 degree. So you do this, right, so all I need to do is to take my ruler, one sec. Right. So what I've essentially done there, I've constructed a 30 degree angle, right? So this angle here, and I'm going to write it in one time. So this angle here is 30 degrees, right? The next thing we need to do, we need to locate where the point N is, right? Because we want to get a 90 degree angle. So what we need to do here is to construct a 90 degree at the point M, right? Now that's very easy to do. All I need to do is to take my compass, place it at the point M. Now I don't know if I have enough. Let me see something here. Yeah, kind of pushing it there a little bit, right? Hold on. I'm just going to extend this line a little bit here, right? That line LM, I'm just going to make it a little longer. Right? I need to make this a little longer. Right, now what I want to do, I want to construct a 90 at the point M. To do that, right, all I need to do is this. You draw an arc like this, right? Then you take the compass, place it at this point here. Now the diagram can get a little complicated sometimes. Draw an arc here. Come on this side. We're going to draw an arc here. We're not done yet, right? There's one more step that we need to do. Bring your pointy part to this end here, and you're going to draw an arc again. Right, and your final step is this. Right, now where those last two arcs intersect, that is going to give me, or that's going to allow me to complete this 90 degree that we want, right? So I'm just going to draw a line from this point here, but it has to pass through what we just intersected it, right? And that's it. I've completed drawing the triangle that they want me to draw, right? So this angle here is 90 degrees, right? And this point here is my N. Right? So you can always go back, play back the video and follow the steps, right, to construct the triangle. That's basically how we're going to construct this, right? So your third question in the exam paper is going to be on geometry, right? So that's why they allowed us to construct something here. Now, in part B now, it's a transformation question. So every single paper, question 3 is normally a transformation question. So they've given us a triangle here, ABC, right? And what do they want? They said triangle ABC is mapped onto LMN by a reflection in the x-axis followed by a reflection in the y-axis. So we have two transformations taking place here. First, you have a reflection in the x-axis, and then you have a reflection in the y-axis. What they want you to do is to locate where triangle LMN is, right? So let's start with ABC, and you're going to perform a reflection in the x-axis. Now, normally the questions that they give us are pretty straightforward, right? So your x-axis is this. This here is your x-axis, right? Now, we're going to do a reflection. So if I want to reflect this triangle here, right? Now I want you to visualize this as you're folding the paper along the x-axis. Where is that triangle going to be located? So the vertices of that triangle will be here, here, right? And from A to B, that's 3 units, so it's going to be here. So this here, right? This triangle here I'm drawing here is after the first transformation, a reflection in my x-axis. That's 1, right? That's the first transformation. Now, so this here is the first transformation. They said followed by, so this is your second transformation now. So you're going to take that image triangle that you just got and you're going to reflect it now in the y-axis. So let's go back here now. So this here is your y-axis. So you're going to reflect that red triangle in your y-axis now. If I reflect that now, it's going to be here, here, right? And it's going to be here. So let's complete this triangle here. So this here is this. Coming this way. And this here, right? Now the thing is, you have to be able to label the triangle properly, right? So they told us that ABC, right, is mapped onto, what do they call it, LMN? Yeah, LMN. So you need to label the triangle properly. There's an error, a mistake that some students make. So A is actually mapped onto L, right? Now, watch where A was. A was originally here, then it moved to this, and then it moved to this. So therefore, this here is L, right? Then we look at B now. B is going to become M. So you start off with B here, then it moves to this point down here, right? And then it ends up here. So therefore, this point here is M, and therefore this last point here has to be N. So be careful with this, because it can impact your answer moving forward, right? So that's my triangle here. That's triangle LMN. And you're getting what? 2 marks for this, 2 marks for drawing that triangle. Alright, so this is part 1 here. Describe fully a single transformation that maps ABC onto LMN. Now, you want to know the transformation that maps this triangle onto this triangle here. That's what you want. Now, the thing is, if you didn't label it properly, some students may say, well, sir, That looking like a reflection in my line y is equal to minus x, right? Some people may say that. But the problem is that if you look at what is actually happening, let's say, you know that B is being mapped onto M, right? So this B here, and this is M here, right? And this is C, and C is mapped onto N. What is actually happening here is that that triangle is actually rotating about the origin. I don't know if you all seen that, but the triangle is actually rotating about the origin, right? So that's why A is mapped onto L, B is mapped onto M, and C is mapped onto N. So the whole triangle is rotating about the origin. So when they tell you here to describe fully, right, and be careful when you see these words there, fully a transformation that maps ABC onto LMN, right? So we need to be careful with that. Right? So the single transformation that maps this thing here is a rotation, right? And it's a rotation of 180 degrees. Now, when you're describing a rotation, there are several things that we want to see. Is a rotation, right, about the point. You need to specify what's your center of rotation. So the center of rotation in this case is the origin, which is 0, 0. So it's a rotation about the point 0, 0. Now, because this rotation is a rotation of 180 degrees, it doesn't matter whether it's clockwise or anti-clockwise. So you can say clockwise or you can say anti-clockwise, it doesn't matter. Right? So rotation about the point 0, 0 clockwise, right? And the angle of rotation here is 180 degrees, right? So these are the things that we need to specify when we are describing a rotation. We have to say whether it's clockwise, anti-clockwise. You must specify the center of rotation and you must specify the angle. That's what you're getting marks for. Right? So that is part 2. Now, this part here, and it's only 1 mark. So if you forget what the matrix is, that's okay, right? They want a single 2 by 2 matrix to represent that transformation. Now this here, we already said it's a rotation of 180 degrees, right, about the origin. Right, so those of you in my class would know that we covered this in class, right? And if we want to know what that matrix is, it's going to be minus 1, 0, 0, minus 1. Now that's something that you just learn, right, just before you go in the exam. So it is minus 1, 0, sorry. So it's minus 1, 0, 0, minus 1, right? So that's the matrix that they're talking about it. Right, so that's the third question. Question 4 now. They said P varies inversely as the square of V, right? So this is a variation question. So if P varies, so we're talking about a proportional sign. So P varies as the square of V. So that means P is proportional to V squared. They want us to write an equation with P and V. Now, if you replace your proportional sign with an equal sign, you need to do this. P is equal to, you must always include a constant. So P is equal to KV squared. 1 mark. That's what I want. This is the answer here. P is equal to KV squared. Now, let me just write down what the formula is. P is equal to KV squared. Now, in all variation questions, we have to work out what this K is. And normally they will give us information to allow us to do that. So if you notice, they said V is 3 and P is 4. So I'm going to substitute those two numbers in order to figure out what K is. So P is 4 is equal to K multiplied by V squared. Now in this case here, V is 3. So this is going to be 3 squared. So 4 is equal to 3 3s are 9. So this is 9K. So therefore K, right? I'm going to write this first because some students have difficulty seeing this. 9K is 4, so therefore K is 4 over 9. So, you know what K is, so therefore you know what the formula is. The formula is going to be 4 over 9 multiplied by v squared. That's your formula. Now the question wants us to work out the positive value of v when p is equal to 1, right? So all we're going to do, we're going to say when p is 1, right? What's going to happen here is that 4 over 9 v squared is equal to 1, right? So I can write that as 4v squared is equal to 9. So v squared is 9 over 4. So v is equal to the square root of 9 over 4. So therefore v is equal to 3 over 2. Now they said the positive value, and the reason why they said that is every time you find the square root of a number, there are actually two solutions, right? So in this case here, the answer is simply going to be 3 over 2. Right? Let me just double check that. I find that the answer looking a little iffy. Hold on. Feel I do something wrong here. Oh, okay. My bad. Right? Hold on. I have an error here. Yeah, I made an error here. My bad, right? Watch what happened here. So they use the word inversely, right? Now, inversely means 1 over. So let me just do this over. So p varies inversely as the square of v. So that means that p is proportional to 1 over v squared, right? So sorry about that, right? So therefore, if I replace the proportional sign, I'm going to get p is equal to k over v squared, right? Yeah, so that's what it's supposed to be. My bad. So p is 1 over, sorry, k over v squared, right? So let me work out k again, right? So v is 3 and p is 4. So therefore 4 is equal to k over v squared, which in this case is going to be 3, right? So therefore 4 is equal to k over 9. And if I cross multiply, I'm going to be k is 9 by 4. So therefore k is 36, right? So therefore your formula is p is equal to 36 over v squared. That's your formula, right? So the last part now, you want to work out v when p is 1. So therefore 1 is equal to 36 over v squared. So therefore v squared is equal to 36. So v is the square root of 36. So v is equal to 6, right? Alright, so that's, we still have an next part to the question. Now they said given that x is a real number, solve this inequality. Now, some students, right, when they see an inequality like this, they get very confused. Now, when you get an inequality where you have two inequality signs in it, right, your objective is to get x in the middle, right? That's your objective. You want to get x in the middle here. So this is what we have. We have minus 7 less than 3x plus 5 less than or equal to 7, right? Now, what you would do step by step, you will remove everything from the middle in order for you to end up with x. So the first thing I'm going to do, I'm going to remove the 5, right? So this is going to be minus 7 minus 5 less than 3x 7 minus 5. So you're removing 5 from every part of the equation here. Minus 7 minus 5 is going to give you minus 12. Put back the sign here. This is 3x. 7 minus 5 is 2, right? Next thing now, I need to remove that 3 that is in front of that x. To remove that 3, all I need to do is to divide every single thing by 3. So this is going to be minus 12 over 3, right? I'm going to end up with my x here less than or equal to 2 over 3, right? So therefore, I'm going to get minus 12 divided by 3 is minus 4, less than x 2/3, right? Hope that making some sense, right? So that is my solution to my inequality for 2 marks. And they want us to represent this on a number line. So let's at minus 4 here, right? So they put in the 0 for us already in the number line. So I need to put where minus 4 is. So I'm going to put a circle here and I'm going to put minus 4. And then I need to put in 2/3, right? So this here, I'm going to put an X circle here and I'm going to put 2/3, right? But here's the thing now. We have to look at these inequality signs. Now that sign there is a less than sign, right? Which means that I'm going to leave this as a circle. I'm not going to shade it. The sign on this side here now, right, is less than or equal to. So therefore, what I need to do, I have to actually shade this here, right? So that's my answer. My solution will be within this region here. So this is going to be a circle by itself, not shaded. And this one here is going to be shaded, right? So your solution actually lies within this region here. It has to be more than this minus 4 here, but it also has to be less than or equal to this. All right, so that's question 4, part 2. The last part of this question here now, we have the equation of a straight line is given by this, and this line crosses the y-axis at Q. Now, lots of students had trouble with this question as well. Whenever we talk in straight lines, and a question like this comes every year in the exam, right? The general form of a straight line is y is equal to mx plus c. Now, if you look at this equation here, the one that they gave us here, when you look at that, you're like, how is that y equal mx plus c? Now, they said it crosses the y-axis at the point Q. So therefore, what they're asking me for here is my y-intercept, right? That's what they want. They want to know what is the y-intercept. So what I need to do, I need to start off with that particular equation they gave me there, right? Which is x over 3 plus y over 7 is equal to 1. So I need to transform this equation. So what I'm going to do, that x over 3, I'm going to carry it across to the right hand side. So you're going to end up with y over 7 is equal to minus x over 3 plus 1. All I've done is taken the x over 3 and carried it across to the right hand side. Next thing, I need to get rid of that 7 on the left hand side here. To do that, all I need to do is to multiply the entire equation by 7. So therefore, I will end up with y is equal to minus 7 over 3x plus 7. Right? Hope I didn't lose people there. Right? So now, this here, that equation is actually in the form y is equal to mx plus c. Right? This here actually looks like mx plus c. Right? Now they want me to determine the coordinates of the point Q. Now remember, c is your y-intercept. So therefore the point Q is simply going to be 0, 7. That's your coordinates. Those are the coordinates of your y-intercept, 0, 7. Right, so that's part 1. Part 2 now, they said, what is the gradient of this line? Well, we already wrote the equation in the correct format already, right? We already wrote it in the form y is equal to mx plus c. So what we did, we wrote it as minus 7 over 3x plus 7, right? Now remember, your gradient is simply whatever this is. So all we need to do is to say that the gradient, right, is equal to minus 7/3. Right, so that is question 4. Question 5. Question 5 is usually statistics. So in this case here, they gave us the cumulative frequency distribution of the volume of petrol needed to fill the tanks of 150 vehicles as shown below. Now, be careful. Some of these questions, they will give you frequency, but in this question here, they give us cumulative frequency. So that's different. They haven't given us frequency. Now, they like to bring this question here. For the class 21 to 30, so we're talking about this class here, 21 to 30. They want to know what is a lower class boundary, right? Now, when you have a class interval, you have something called lower class boundary, upper class boundary. In this case here, your lower class boundary is simply found by taking this 20, add it to this 21, and divide by 2, right? Which works out to 20.5, right? That is my lower class boundary, 20.5. Some students might say 21, but it's actually 20.5, right? Now, the next part of the question here, they want to know what is my class width. Now, this is also a question that people tend to get wrong. So, for your class width, some students might say 30 minus 21, and they'll get 9 for the answer, but that's incorrect. Your class width is found by taking your upper class boundary and minusing your lower class boundary. You have to be careful with this. So your upper class boundary in this case here is actually 30.5, and your lower class boundary is actually 20.5 for that particular interval. When I subtract this here, right, 30.5 minus 20.5, I'm going to get 10 as my answer. The answer is not 9. Some students will actually put 9 as the answer, right? So be careful. Right, so that's your class width. Class width is 10, right? And if you want units, so in this case it's 20.5 liters, and this here is also liters as well, right? Based on this here. Now, the next part now, part B, they want to know how many vehicles were recorded between 31 to 40, right? 31 to 40. Now, remember I said at the beginning, you have to look and see what they gave us here. They gave us cumulative frequency. They have not given us frequency, right? What we need to do, we need to work backwards now. We need to try to work out what is my frequency. Now, cumulative frequency means that I keep adding up, right, as I go along. So in this case here, this is something. They want to know 31 to 40, right? They want to know 31 to 40. So they want to know what is the frequency, what is the actual frequency for that interval. Now to do that, you are jumping from a cumulative frequency of 59 to 101, right? So therefore, if you want to work out what is the what is that amount, all you need to do is to take 101 and minus 59. That's all you need to do, right? All you need to do is to take that 101 and subtract 59. So this here is going to be 101 minus 59. Is it 59? Yeah, 101 minus 59, right? And you're going to get 42, right? So that's your how many vehicles in that interval. So you have to be careful with that. The next part, part C, a vehicle is chosen at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill the tank is more than 50.5? And they want me to give my answer, right, as a fraction. They want me to leave the answer as a fraction. So you're selecting a vehicle at random, right? And we want to know if it needed more than 50.5 liters. So let's go to the diagram, right? Now there's a reason why they said 50.5. 50.5 is actually the upper class boundary for this here. 50.5 is here. Now, they want you to work out the probability that the vehicle selected at random, right, uses more than 50.5. Now, up to this point here, right, we have a cumulative frequency of 129, right? Now, the more than is going to be this interval here. So we're looking to see what happens to the frequency when we jump from 129 to 150, right? So we need to work out the actual frequency in that interval there. So what we need to do, we need to take 150 and subtract the 129, right? So the probability, right, that the vehicle uses more, so the volume is more than 50.5, right? We need to figure out first how many cars actually do that. So to get that, we're going to take the 150 minus 129, and you're going to divide it by the total number of vehicles, which is 150. So this is going to be 21 over 150, and I think that could reduce. Yeah, you're going to get 7 over 50. Right? So that's your probability there, 7 over 50. Byron estimates that the median, are we talking about median here now, right? Explain why Byron's estimate is incorrect, right? The median petrol is 43.5. Now, I've seen them brought this in several different papers, right? Now, you have to be careful when you're doing a particular question like this. So, median, what you'll have to do is to arrange your data in ascending order and find the middle. That's what median means, right? Now, you have 150 cars here. So, what I would do, I would take 150 and I will divide that by 2, right? So, 150 divided by 2, you're going to get 75. Right? So what I'm looking for the location of my 75th car, right? Now, how are we gonna check this? Now, this question here is only 1 mark. Now, if we look at the cumulative frequency, so in this interval here, we have 24 cars, right? In this whole thing here, we have a total of 59 cars. We've summed up 59 cars already, right? Now what we do, we're trying to check to see where is our 75th car, right? Now, when you, so this point here we have 59, and in this one here we have 101, right? So as it stands, right, it looks like his estimate, right, may actually be incorrect, right? Because, let me tell you why. One second. All right, so we have, right, so we're looking for the 75th car. Let me go back here. And where did he say it is? Right, so he's saying the median is about 43.5 liters, right? But if you look, our median really is located here. So it can't be 43.5. It has to be somewhere between 31 and 40. So he's incorrect, right? So the 75th, so how you're explaining this, right? You're going to say the 75th vehicle is in the interval (31 to 40), right? So therefore, Byron is incorrect. Now this is only 1 mark, right? So there's, you don't have to go into too much details here, right? But Byron is incorrect. It can't be 43.5. It has to be somewhere between 31 and 40. Right, so that's part D, right? Now the last part of the question here, they want us to construct a histogram, right, to represent the distribution of the petrol, right? Now, a histogram is a diagram where all the bars are next to each other, right? So what you will have to do in a question like this, right? Let me just erase some of these things here. Hold on. So before I can even draw this, right? Yeah, before I can even draw this, I need to actually work out what is my frequency. I need to know the frequency before I can do anything. Right? So you're working backwards now. Normally in an exam question, we'll have to work out what is our cumulative frequency, but you're working backwards this time. So in this case, in the first interval, the frequency will be 24, right? For the next one, it'll be 59 minus 24. So you're going to get 35 here, right? The next one will be 101 minus 59. This is 42. Right? The next one will be 129 minus 101. This will be 28. And the last one there is 150 minus 129. And you're going to get 21. Right? So you need to work out this before you can construct anything. You need to get the actual frequency. Right? Now, you're going from 11, right? Your smallest volume is 11, and you're going up to 60. So we need to select a scale that is most suited for the data that we have here, right? So what I would do in this case here, I will probably go 10, 20, 30, 40, 50, and 60, right? Now you're drawing what they call a histogram here, right? So what I would do, let me show you what happened here. Now, we're going to draw bars here, right? But these bars here, they are going to, the first bar is going to be from 10.5 to 20.5, right? So that's the width of this bar we're talking about here. So 10.5 to 20.5. Right? And that frequency corresponds to 24. So that is going to be here. Right? So that's my first bar that I'm going to draw. Remember, it's a histogram we're drawing, so be careful. Next bar is going up to 35. So again, one sec. So this second bar that we're drawing here now, right? This bar is going up to 35, right? So you're coming up here. Right? So this is what we call a histogram. Right? The bars are joined to each other, right? And what we're doing here to get the size of this thing, we're using the class boundaries, right? So that's the next one. The next one is from, right, next one is 42. Alright, so we're around here. Alright, that's 42. And the next one is 28. So that's about here. And the last one is 21. It's 20, right, and that's 21. That's it, right? So that's my histogram here. Right, so that is question 5, right? Now question 6 now is based on measurement, right? Some students like these questions, some don't, right? Now, we have a scale here. We have to understand how to use a scale. So scales are used on maps. Now in this scale here, they are telling us that the scale is 1 to 25,000. Now what does that really mean? That tells us something. That means that 1 cm on the map, right, represents 25,000 cm. That's what they're telling us, right? Now, the question wants me to know the actual distance in kilometers if I have 0.5 cm on the map, right? So check this out. If 1 cm represents that, it means that 0.5 cm, right, is going to be represented by half that amount. So I'm going to take 25,000. I'm going to divide that by 2, right? So 25,000 divided by 2, you're going to get 12,500. So this is going to be 12,500 cm. But the problem is, they said they want the answer in kilometers. Now, some students, they learn off conversion factors. You can if you want, but I tend to work a little smarter than harder. So if I want to convert cm into meters, right, all I'm going to do here is to divide by 100. So to convert from cm to meters, I'm going to divide by 100. So if I divide by 100, I'm going to get 125 meters, right? And if I want to convert to kilometers now, all I need to do is to divide by 1,000. So to convert from meters to kilometers, I'm going to divide by 1,000. So this is going to be 0.125 kilometers, right? So that's going to be my answer there, 0.125 kilometers. Right, so that's my linear scale here. 1 cm represents 25,000 cm. So therefore, if I know a measurement on the map, I can work it out in actuality, right? All right, so this one here now, this one carries a little more marks, and this is one that students generally get wrong in the exam, right? They're talking about area, and they're talking about area in kilometers squared, right? Now, watch what I would do here in a particular question like this. So 1 cm on the map represents 25,000 cm. So let me start with that. 1 cm, right, represents 25,000 cm, right? That's what the scale is telling me, right? Now, we need to write the scale in terms of an area, right? Now, to get area, right, all I need to do, so I want you to visualize this. On the map, visualize a box, a square that is 1 cm by 1 cm, right? Now, in actuality, what's going to happen is that the actual area is not going to be, what it's going to be here is 25,000 cm by 25,000 cm, right? So this here, this small square, right, has an area of 1 cm squared, and this here, right, has an area of 25,000 multiplied by 25,000 cm squared, right? Now, what some students do, instead of working in cm here, right, what they will do is this. So let me just convert, right? I'm going to convert this 25 cm into kilometers one time, right? We already know what this is. We just said that it's 0.125. So let's put that in kilometers one time. So this here is 0.125 km, right, by 0.125 km, right? So what that means is that 1 cm squared, right, is actually represented by 0.125 multiplied by 0.125, right, and that's going to give me 0.015625 kilometers squared, right? So that's my conversion. This is what I need to work out the question, right? This is what I need in order to work out that question there. Now, they're telling us that on the map we have an area of 2.25 cm squared. So we already know that 1 cm squared, right, represents 0.015625 kilometers squared, right? So therefore, to work out for 2.25 cm squared, all I need to do is to take that 2.25 and multiply by that long number there. So this is going to be 2.25 multiplied by 0.015625. And this is going to give me my answer in kilometers squared, right? And I'm going to get 0.0352. I hope that makes a little sense for some of you guys. Let's make sure that answer is correct, right? 0.125. Let's double check my answer. That's all I do, right? 15625. Looks correct. Anybody seen any error there? Alright, so let me just do the next part then, right? Alright, the next part here, we have a diagram below, not drawn to scale, shows the cross section of two cylindrical jars, jar X and jar Y, right? So we're talking about two cylinders here, right? They said the diameter of jar X and jar Y are 3D and D respectively. Initially, jar Y is empty and jar X contains water at a depth of 4 cm. So they want us to determine in terms of pi the volume of the water in jar X. So we're talking about a cylinder. So volume is pi r squared H. You all need to know that formula. It's not given to you in the exam, so you need to know it. So it's going to be pi multiplied by, we're talking about the first jar, right? Now this here, right, is your diameter, right? So therefore the radius of this thing here is going to be 3d over 2. I have to divide that by 2 to get my radius. Then you're going to square that, and you're going to multiply that by the height, which in this case here is 4. That's the depth of the liquid inside it. So we need to simplify this now. So this is going to be pi multiplied by 3 3s are 9. So this is 9d squared over 4 multiplied by 4. So therefore this volume here is going to be 9 pi d squared, right? That's what this is going to be. Right, so that's your volume for your liquid in jar X, right? Now, all of the water in jar X is now poured into Y. Calculate the height reached. Now, this is a typical exam type question that CXC likes to bring up. So you have a liquid in this container, but we're pouring it into this container here, and it's going to go up to some height, right? That we don't know. We don't know what that height is, right? But you know that all the liquid is going to be poured into that container. Now, let's look at jar Y. Again, we're going to be using the same formula. Y is equal to pi r squared H, right? But the thing is, you're pouring all the liquid from the first container, right? So you know what the volume was. That was the volume, 9 pi d squared. So this here is going to be 9 pi d squared is equal to pi multiplied by the radius of jar Y, which in this case here, you have to divide this by 2. So it's d over 2. Multiplied by the height, which you don't know. So what you're trying to do, you're trying to solve for this height here. So this is going to be 9 pi d squared is equal to pi multiplied by d squared over 4 multiplied by H, right? Now, what we can do is multiply everything by 4. So this is going to be 9 4s are 36 pi d squared is equal to pi d squared H, and therefore H is equal to 36 pi d squared over pi d squared, and therefore H is going to be equal to 36 cm. Right? So that's your height of the liquid there, 36 cm. Right, so that's question 6. Question 7, right? Normally your question 7 in the exam paper is your investigation question. This is the first time that CXC brought a particular question like this. Lots of students had great difficulty with this, right? So the nth term of a sequence, right? So they have a sequence here. Now a sequence is simply a set of numbers that follow a given rule. So what they've done, they've given us what the rule is. The rule is your nth term is equal to 3n squared minus 2. And they want you to show that the first term in the sequence is 1. So what they're really asking us to work out here is T1, your first term. So all we have to do is to substitute 1 into my formula. So it's going to be 3 multiplied by 1 squared minus 2. So this is going to be 3 minus 2, which is 1. So that's it. We proved that the first term is 1. Next part. What is the third term in the sequence? Again, you know the formula. Your nth term is given by 3n squared minus 2. Right? And you want to work out the third term, so that's t3. So this is going to be 3 squared minus 2. So 3 3s are 9 3s are 27 minus 2. And you're going to get 25. Right? So your third term here is going to be 25. So some students manage to get some marks there, right? But then they weren't sure what to do here. What they've done here, they said that Tn is 45. So Tn is 145. But you know the formula for Tn. Formula for Tn is 3n squared minus 2. So what you're trying to do here is to figure out what n is. So all I need to do is to put 3n squared minus 2 is equal to 145. 3n squared is 145 plus 2. 3n squared is 147. N squared is 147 over 3. You're going to get 49. So therefore n is the square root of 49. So therefore n is going to be 7. Right? Getting plenty marks for this, eh? Right? So even if students made it to this stage of the question, many of them had no clue how to work this part out. And that's understandable, right? Now, this is part B here. They said the first 8 terms of another sequence, right, with nth term. So what they're telling us now here. So with a sequence, you can represent a sequence. You can say nth term. You can say Tn. You can also say u small n. Or in this question, they are calling it u. All of these represents my nth term. Right? Now, if we look at this pattern here, right, you have 1, 1, 2, 3, 5, 8, 13, 21. So this is a very popular sequence here. It's called a Fibonacci sequence. If I add 1 plus 1, I'm going to get 2. If I add 1 plus 2, I'm going to get 3. If I add 3 plus 2, I'm going to get 5. So what I need to do to get my current term is to add the 2 previous terms, right? Now, this is where things got a little confusing for some students, right? So your first term is 1, your second term is 1, and your nth term is given by this formula here, right? And they give us an example. They said write down the next 2 terms in the sequence, that is u9 and u10, right? So what we have so far, we have 1, 2, 3, 4, 5, 6, 7, 8, right? So we need to work out u9. So u9 is simply going to be 13 plus 21, right? Which is going to be 34. That's your 9th term in this particular sequence, right? Hope that making some sense, right? And we need to work out the next one now. So that's u9. We want to work out u10. So to get the 10th term, now the 10th term is actually u8 plus u9. That's how we're working it out, right? So in this case here, your u8 is 21, right? And you're adding that to 34, right? And that's going to give you 55. That's your next term in the sequence, right? Like I said, lots of people, they could not do this part of the question at all. right? What else we have to do here now? All right, so which term in the sequence is the sum of 18 plus 19? Well, this is a very easy part. If I'm adding my 18 term and my 19 term, I'm obviously going to get my 20th term, right? Remember, to get your current term, right, add your two previous terms. So if I add 18 plus 19, I'm going to get my 20th term, right? Hope that makes some sense. For this last part here, lots of people just left it out, right? Lots of people just left it out. They said show that U20 minus U19 is U19 minus U17, right? So if you look at it here, you have 20th term, 19th term, you have 19th term and 17th term. So let's look at them in order. So let's go 17, there's a U17. There is a U18, there is a U19, and there's a U20, right? So those are four terms in order, 17, 18, 19, and 20. But if you look at the what I want us to show, you notice that there's no U18 there at all, right? Now, what I'm going to do, because it's a Fibonacci sequence, when I take 17 and add it to 18, I'm going to get 19. So U18 plus U19 one sec. Sorry, U17 plus U18, right? I'm going to get U19, right? So that's one expression I can say for sure, right? So U18, right, is simply going to be U19 minus U17. Right? So that's when I'm looking at this term, and this term, right? But I can also look at these three terms here, 18, 19, and 20. I can say that my 18th term plus my 19th term will give me my 20th term, right? So therefore, I can say that U18, your 18th term, is simply U20 minus U19, right? Now, if you notice now here, you have an expression for U18 in two different ways, right? So this here has to be equal to this, right? So therefore, U20 minus U19 is equal to U19 minus U17, which is what it told us to prove, right? That's what it told us to prove there. So what I did, I worked out an expression for U18 in both instances and put them equal to each other. Right, so that is question 7. Let's move on to question 8, which is a functions question. So the function f and g, so they gave you two functions here. This is function f and this here is function g. State the value of x that cannot be in the domain, right, of f. Now if you all remember what a function looks like, we have a domain and we have what we call a codomain, right? And the range is a subset of the codomain, right? Now they said which value cannot be in the domain. So your domain are the numbers that you plug into the function. So if you look at this particular function here, right, it's a fraction. Now what you don't want to happen is that the denominator equal to 0. You don't want that equal to 0. Because remember, in one of the earlier questions, I said 0 divided by any number will give me 0. However, any number divided by 0 is undefined, right? So we never want this to happen with a function. So what I'm going to do here, right, I'm going to take this piece here, 2x plus 1, and I'm going to put that equal to 0. So 2x is equal to minus 1, and x is equal to minus a half. So this is the value we're talking about here. If you plug that into that function, right, you're going to get a problem. You're going to get a function being undefined. Right, so 1 mark for that. The next part, they want you to work out fg of x. So this is a composite function. So f of x is equal to 9 over 2x plus 1. And g of x is equal to x minus 3. Right, now you want to work out fg of x. Now you have to understand how to read this. So what we're going to do, you're going to take this g and you're going to plug that into your function f. So this here is my g, and I'm going to plug that into my function here, right? So this is going to be 9 over 2 multiplied by x minus 3 plus 1. So we need to simplify. So this is going to be 9 over 2x minus 6 plus 1. So therefore this is going to be 9 over 2x minus 5. Right, so that's my answer for that one there. The next part, they want us to work out the inverse of that function, right? So remember, f of x was 9 over 2x plus 1. Now, when you want to find the inverse of a function, there's a process that we follow. Step 1, you're going to say let y equal to 9 over 2x plus 1. The next step of the process is to interchange x and y. Meaning, anywhere you see x, you put y. Anywhere you see y, you put x. So this becomes x is equal to 9 over 2y plus 1, right? And what I'm going to do, I'm going to write this as x over 1 so I can cross multiply. So this here is going to be x, open brackets, 2y plus 1 is equal to 9. 2xy plus x is equal to 9. So we're making y the subject of the formula. That's the objective here right now. So 2xy is equal to 9 minus x. So y is equal to 9 minus x over 2x. So therefore the inverse function here is 9 minus x over 2x. Alright, so let's move on to, we have a next part here. So, now, this particular question here, CXC has brought something similar to this in the past. I've seen a question like this previously. So, we have a diagram here. We have two rectangles, and they are telling us that the area ABCD, so that's a big rectangle, right, is 44 cm squared. So, they give us some dimensions, and what we want to do, we want to show that area ABCD is, you can write the equation as this here, right? That's what we're trying to show. Now, okay, I need some space to work this out for you guys. Okay, this is what we have here, and we know the area of ABCD is 44, right? Now, area of ABCD, right, we know it's 44, right? But to get that area, right, you need to know this length and you need to know this length here, right? When you multiply that, I should get 44. So therefore, I have 3x plus 4, that's one length, and I'm multiplying that by the other length, which is 3x plus 2, right? When I multiply those two lengths, I'm going to get 44, right? Now, what we're trying to prove is this. X squared plus 2x minus 4 is 0. That's what you're trying to prove. X squared plus 2x minus 4 is equal to 0. Yeah. So let's start. If you want to remove the brackets here, right, you're going to have to take the first term and multiply by every single thing in the second term. That's what you're going to do first. So 3x by 3x is going to give you 9x squared. 3x by 2 is going to give you 6x. Next thing we're going to do, we're going to take this 4 and multiply by this 3x. So that's going to be 12x. And then I'm going to take this 4 and multiply by this. So I'm going to get 8 is equal to 44. Now, next thing I'm going to do is carry everything across on the left hand side. So 9x squared plus, this is 6 and 2, 8. So this is 18x plus 8 minus 44 is equal to 0. So 9x squared plus 18x. 8 minus 44 is minus 36. And that's equal to 0. But we're still not there yet, right? Our answer does not look like what they tell us as yet. So if you notice, they just have x squared. So what I'm going to do, I'm going to divide everything by 9. If I divide by 9, things might make more sense. So 9x squared divided by 9 will give me x squared plus 2x, right, minus 4 is equal to 0. And that's it. I've just proven what they wanted me to prove. Right. Next part of the question. Calculate to 3 decimal places the value of x. Now, what we have here, guys, we have a quadratic equation, which is x squared plus 2x minus 4 is equal to 0. That's a quadratic equation. But you see, when they tell us that they want the answer to 3 decimal places, that's telling us that you cannot factorize this. You have to use either completing the square, or we can use a formula in order to work this out, right? Now, your general formula for a quadratic is ax squared plus bx plus c is equal to 0, right? Now, that means that a is 1, b is 2, and c is minus 4. That's what that means. Now, there's a formula, right? And this formula is given to you in the exam. X is equal to minus b plus or minus square root. Hopefully you all remember this formula. This is something you would have done maybe in Form 4. Right? So all I'm going to do now, I'm going to substitute. So it's minus b. So it's going to be minus 2 plus or minus b squared. So this is going to be 2 squared minus 4 by 1 by minus 4. Square root all over 2 by 1. So this is minus 2 plus or minus. I'm going to work this out one time here. So that's 2 2s are 4 plus 16. So this is going to be the square root of 20 over 2. Now, because it's a quadratic, I am going to get two solutions. So I can say either x is equal to minus 2 plus the square root of 20 over 2. That's one solution, right? Or I can get x is minus 2 minus the square root of 20 over 2. So let's see what we get in here. So I'm getting 1 point, they want to answer the 3 decimal places, 1.236. And the next one I'm getting is negative 3.236. Right? Now, we're talking about a length here, right? So the answer that we're going to use is x is equal to 1.236 cm, right? We're talking about length, so it has to be positive. So this is the answer that we're going to take. Right? And now they want you to calculate the perimeter of the unshaded region, right? Perimeter of the unshaded region. So let's copy this diagram across here. So this is my diagram, and they want us to work out the perimeter of the unshaded region. So that's here, plus this length here, plus this, plus this, plus this, right? So that perimeter they're talking about there, let's write it in terms of x. So it'll be 3x plus 2, right? So I'm adding this length here. That's 2. This one here is going to be 4 plus our next 3x. All right, that's this length here, plus this here, which is 3x plus 4. So plus, right? Make sure I add all the lengths here. I should have 1, 2, 3, 4, 5, 6. Right, I have one more length to add, which is 2 plus 3x. Right, now let me just simplify this first. Let me add all the x's. So 3x, 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 3x. So that's 3 and 3, 6 and 3, 9 and 3, 12. So this is 12x. And then I'm going to add the numbers. So that's 2 plus 4, 6 and 3, 9 and 4 is 13 plus 15. So then all I'm going to do is to substitute the value we just got for the length, which was 1.236. And I'm getting 29.832 cm. All right, let me double check that, make sure I didn't make a mistake. 416. Yeah, I have an error. This is not 15, it's 12. 4126 and 410. Yeah, this should have been 12 here, right? So it should be 12x plus 12, right? So this will give me 26.832. Right, so as you can see, sometimes it's very easy to make a mistake in a question. Very, very easy. Right? All right, let me see if I can do question 9 for you guys quickly. All right, so question 9 is circle geometry. You will more than likely get a question on circle geometry. It comes every year. So they have a diagram here, and they want us to calculate the following angles, show detail working when necessary. Right? So let me get a diagram here first. Alright, so this is my diagram here, right? And they want us to calculate angle DBA. So where's DBA now? DBA is this angle here. When you guys have an exam question like this, right, what you need to do is to make sure you understand exactly which angle they want us to work out, right? Now, you're going to be applying certain rules in order to work this thing out here, right? Now, you want to get this angle here, right? If you look carefully, right, this here, A and B forms a chord, right? So this angle here that we want to work out should be exactly equal to this other angle here. Should also be equal to this angle here. Now, we have to use some of the rules in order to work out these things. Now, AC is a diameter. Now, what does that tell me? That tells me that this angle here has to be 90 degrees, right? So watch this. Angle ACB, I'm going to write down this first. ABC is 90 degrees, right? That's one of the rules. Angle in a semicircle, right, is 90. So we know that's 90. So I can work out ACB. ACB is simply going to be 180 degrees minus 28 plus 90. You're going to get 62 degrees, right? You're going to get 62 degrees. So therefore, ADB is also 62 degrees, right? So they always want you to give the reasons, right? So in this case here, what I'm really using is the fact that the angles in the same segment are equal, right? Because I'm calculating this angle here, and because I know this angle, I know what I know what DBA is, right? Wait, hold on. What do you want me to work out? Hold up a second. Hold up. Working out DBA. I'm trying to complicate the problem. Right, so DBA, right, so DBA is this here, right? Yeah, I complicate any problem. It's much easier than we think it is, right? Okay, so A, B, C is 90 degrees. So we know that, right? Now, if you want DBA, so DBA is simply going to be 90 minus 46. That's all, right? 90 minus 46. So I'm finding angles that it didn't ask me to find. So the answer for this one is 44. That's all. What else do you want me to work out now? DAC. Right, so we know here is 44. And they want DAC. So now they want this angle here. Right? Now that angle there is pretty straightforward because DC is a chord, right? And if this angle here is 46, it means that this angle here also has to be 46. So DAC is 46 degrees. And the reason that we're going to give them is angles in the same segment are equal. Right? We have one more angle to work out. So we know this was 46. We know this was 44. Right? And when you're doing a question like this, write in the angles that you do know because it'll help you. So we want BCE. Where is BCE? So BCE is this angle here. That's what we want to work out. Right? So that particular angle there, right, follows another rule, right? So let's see. So let's try to write down all the angles that we do know, right? Now, if I want to figure out this angle here, which is BCE, what I can do, what do I know? I know this angle here. This angle here has to be 28 degrees. So that means I can work this out here. I can work out this, right? Yeah, I can work that out, right? So angle DCB is simply going to be 180 minus 28 plus 46. So that is 106. Right? So if I know that angle is 106, then I can easily work out what, so therefore BCE is simply 180 minus 106. And you should get 74 degrees. Right, so I think we just have one more part here. Let me just do that part quickly. All right, so we have a diagram here. It shows a quadrilateral, right, PQRS, and they said that PQ and SR are parallel. So that means that this here is parallel to this. So therefore, the diagram that we're looking at there is a trapezium. That's what we're looking at, right? Now, the first thing they want me to work out this length here, right? They want us to work out this length PS here. Right now, since PQ and QR are parallel, right, it means that this angle here has to be 30 degrees. This angle has to be 30 degrees. So I have a right angle triangle, right, and I want to work out that length here, which is what we call my opposite, right? So we have opposite, we have hypotenuse. So therefore, to figure out PS, I'm going to use sine. So therefore, sine theta is opposite over hypotenuse. So therefore sine theta is equal to PS, which you don't know, over the hypotenuse, which is 8. So what I'm going to do, I'm going to cross multiply. So PS is equal to 8 multiplied by sine theta. So therefore PS is equal to 4. Right, so PS is 4 cm, right? So that's pretty straightforward. The next thing that we want to work out here is PQ. Where is PQ? Right, so PQ is from this point here to this point here. Again, I can use the right angle triangle there. And I could use Pythagoras' theorem, or I can use one of the other trigonometric rules, right? I'm going to use Pythagoras' theorem to work out PQ. So PQ squared, right, is equal to, or PQ squared plus, let's say, PS squared, right, is equal to a hypotenuse squared. That is what Pythagoras' theorem is, right, which is SQ. So PQ squared plus PS was 4, right, is equal to 8 squared. So PQ squared is equal to 8 squared minus 4 squared. So that's 64 minus 16. That's 48. So PQ square root of 48. And you get about 6.93. Right? That's about 6.93. Right? right? And we only have one more part to the question now, and they want me to work out the area of PQRS. So it's a trapezium, right? And we need to work out the area of this trapezium here. So there's a formula for the area of a trapezium. It is given by a half the sum of the parallel sides multiplied by the distance, right, between these two sides, right? That's the formula for the area of a trapezium. Now, do we have all this information? We know this is 4 cm, so we have this. We also know what PQ is. PQ is 6.93. So this here is 6.93. So the only dimension I'm missing, I need to figure out what is SR, right? You need SR in order to do that. Now, SQR is a triangle, but it's not a right angle triangle. So we have to use either sine or cosine in order to do this, right? So what I'm going to do in this case here, I have a side, I have two angles, and I want to work out another side here. So therefore, I'm going to use my sine rule, right? So you're going to say using the sine rule. Right? Now the sine rule is a length. You're going to take one of the lengths. So SR, we don't know what SR is. Divided by sine, the angle that is opposite SR, which is 82. So this is sine 82 degrees, is equal to another side in the triangle, which is 8, right? Or, let me see something here. Okay, well, we need to figure out this angle here in order to use the sine rule, right? So that's going to be 180 minus 82 plus 30. So this angle here is 68 degrees, right? So it's going to be 8 divided by sine 68. Right? So therefore, SR is simply going to be 8 multiplied by sine 82 all over sine 68 and I'm getting 8.54, right? So this here is 8.54 cm, right? So therefore the area of that trapezium is given by this formula. So it's a half multiplied by the sum of the parallel sides, which is 6.93, and the length we just got. So 6.93 plus 8.54, right? Multiplied by the height. What was that height? The height was 4. Right? I'm getting 30.94. Right? So that's my area of my trapezium. Right? Alright guys, so we only have one more question there, right? But this is all the time I have to give you guys today, right? I hope it was helpful, right? Like I said, if you want more recent solutions, you can find all of them on the YouTube channel, right? So all I needed to do is just hit like and subscribe, right? And that's it for now, guys, right? Any questions before I go? Alright guys, so that's it for me for this afternoon. Right? Take care everybody.